Oh, hey there, come on in.
Hi Angie, how are you?
All good, how are you?
Good. Can I ask you a couple questions?
Of course, bring them in.
Where are we right now?
So, we're in the basement of Fitzpatrick. This is my lab.
Awesome. Who's your advisor?
Well, I work with Kyle Doudrick in the CS department. He's my advisor, and my co-advisor is Bill Phillip on CBE.
Awesome. What are you doing right now?
Well, I was about to start checking on some data and some experiments.
Cool. Could you tell us a little bit about your research?
Of course. Do you know that nitrate is one of the most widespread contaminants in groundwater and drinking water? Nitrate, as other contaminants, form oxidized compounds. These oxidized compounds are not good for our health. They cause many diseases such as baby blue syndrome and are precursors of cancer. These contaminants are mainly found in groundwater and other sources of water because of artificial and natural fertilizers. The way to treat these contaminants usually is through heterogeneous catalysis, but using this type of technology could be expensive and requires a large footprint, and not to mention that sometimes it has mass transfer limitations because it needs a lot of space for the contaminant to travel into the catalysis. This is This is why my research focuses on developing polymeric catalytic membranes with palladium nanoparticles to treat these contaminants. Our engineered membrane has a high capacity, high removal efficiency. It uses nanoparticles, so it's a little bit more inexpensive and could be implemented in existing facilities, so it doesn't require a large footprint.
That sounds really cool. What got you into water-related research?
Well, that's a good question. I study environmental engineering as my undergrad, and I realized that, of course, one of the biggest problems right now is how to provide clean and safe water to everywhere. And living in Mexico, of course, I grew up there, and I could notice that there's a huge crisis of water, and it's really hard for countries to spend a lot of money having to build new infrastructure for better technologies. Therefore, having a facility that can allow you to improve it and remove some of these invisible contaminants that mostly water treatment plants do not treatment, it was a pressing matter. So I decided to go into this field.
That sounds amazing. What makes you most excited about your research?
Well, of course, I would say that contributing to provide safe water to everyone it's the most exciting thing. But also making new materials or catalytic membranes have a lot of potential to be used not only in water treatment plants but also in houses. So imagine having this type of technology cleaning your house. So I think that synthesizing and characterizing my material is what excites me the most.
Great. What do you think is the most pressing water-related challenge?
Well, there are many challenges right now related to water. But in my area, I would say that the emerging contaminants. These emerging contaminants include PFAS, microplastics, halogenated compounds, antibiotics, and so on. These compounds are found in water and are mostly invisible. Not every water treatment plant treats them. I would say almost none. And they are not super visible right now in terms of laws and administration because they are in really low quantities. But we still don't know about the effects that those could carry for our health. So I think emerging contaminants are something to be aware of.
Great. How do you think you or your research area can help solve this challenge?
Well, we are studying the fate and the transport of these contaminants in water sources such as groundwater, lakes, and streams, and so on. But we're also looking at how to eliminate these contaminants in water. So we're developing new technologies like membranes, like absorption techniques, incineration, etc., to try to remove them from our sources.
Great. Can you share an example of how you benefited from interdisciplinary research in the water sector?
Of course. So before making all of these technology and all of these new materials, of course we had to study this composition. So I benefited from the area of material science and engineering and environmental engineering. So I get the technology and the basis of cleaning water from environmental engineering and all the pollutants, but I get the same synthesis and the characterization techniques from material science. Without this collaboration, I wouldn't be able to see what's the structure of palladium, what's the porosity of my membrane, what is the, I don't know, the quantity of palladium that's in my membrane. And that's how we can make a good collaboration and get these materials.
Amazing. Thanks for your time.
Thank you. Come another day.
Bye.